So this example is pretty similar to the previous one in that we're looking at a Young's modulus situation, but this time it's for a nylon rope. So the Young's modulus of nylon rope is 3 times 10 to the 9 pascals, and it says how much would a nylon rope stretch under 2,500 newtons of force if the rope is 25 meters long and has a diameter of 1.5 centimeters. So again, I've already put up some of the stuff from the previous example. We've got these two formulas, so we're probably going to wind up using this one. The Young's modulus had to change, but the amount of force applied is still 2,500 newtons. The length of the rope is still 25 meters. I think before it was a cable, though. One thing that's a little bit different now, though, is that the diameter given to us is 1.5 centimeters. I think it was half a centimeter before, right? But that implies a radius of 0.75 centimeters, which is really equal to 0.0075 meters, which means we can calculate an area based on that by saying pi multiplied by 0.0075 meters squared. That's really pi r squared that I'm doing there, and then I can turn to the calculator for that one and get 1.767, maybe good enough. That's four significant digits there I've included, but it's times 10 to the minus 4 in meters squared, so I could use that number. As before, the question is for the amount of stretch. Okay, so again, we're going to use this formula to do that, and so that means I'm going to really wind up doing 25 meters, and then I'm going to go to I'm going to keep F upstairs like I did in the last one too, times 2,500 newtons divided by that 1.767 times 10 to the minus 4 meters squared, and we also need the Young's modulus down there of 3 times 10 to the 9 newtons per meter squared. And again, the units kind of all work out. There should be something in meters. And when I put this in my calculator, I get like a 0.117, etc., which maybe I could round off at two significant figures to 0.12 meters, but really isn't that just equal to 12 centimeters? So looking at this problem, that's the one I expect to match just if I use sig figs. And I want to say again, because I haven't maybe said it a little bit, is that I'm actually not horrendously picky about that, but in my slides I'm usually trying to match my answer. Sometimes I don't succeed, right? But hopefully this will work out there. What's interesting though is, so like I'm kind of maybe setting up a bit of a comparison between a nylon rope versus, what was it before? I think a steel cable. And the steel cable, how much did it stretch by in the last example? I think it was only like 1.6 centimeters, and this one stretched by a whole 12 centimeters. So we can definitely see how that different Young's modulus, even though this was thicker, right? This was a thicker nylon rope, but it still stretched a lot more because of how much smaller that Young's modulus is for nylon.